everyone. I am Ayush from the Funtastic Academy. Today we are going to learn something totally new. But before we learn that totally new thing, it's time for last episode's quiz question. What is the modern name for aluminum? Answer: gallium. It's named after God, the word for France, where the inventor was from. Okay, we've covered gallium. Now we can talk about something totally new: electron configuration and Aufbau rule. Sounds exciting? It sure does. So let's dive in. Remember in the atoms episode when we talked about the Grand Atom Hotel? Well, each of these rooms is a floor in the hotel, and these floors are called shells. Now each shell is divided into subshells. There are 4 types of subshells: S, P, D, and F. Now each subshell is named with the shell it's part of, and then the type of subshell it is. So shell number 1 has only one subshell, 1s. It's in the first shell and it's of type S. Shell number 2 has 2 subshells, and those 2 subshells are 2s and 2p. Now each of these subshells are divided into orbitals. How are they divided into orbitals? Well, let me explain. So these S subshells, they're like balls. So these balls can only be in one formation. Each formation is an orbital. And these orbitals can hold 2 electrons each. So the S can hold 2 electrons. Meanwhile, the P is like a dumbbell. Now, there are 3 ways you can configure the dumbbell. You can configure it like this, or like this. So there are 3 ways, meaning 3 orbitals: px, py, and pz, which means the p orbital can hold 6 electrons, d can hold 10, and f can hold 14. Okay, so let's say I want to figure out the configuration for oxygen. How do you do it? Look at the subshells. So this is 1s, this is 2s, and this is 2p. Great. So how many subshells do we need to get the oxygen from hydrogen? Well, it's simple. 1s, 2s, 2p. But how many steps do you need to go? Well, 1s you need to go 2 steps, 1s2. 2s you need to go 2 steps, 2s2. So 1s2, 2s2. In 2p you need to go 4 steps. So 1s2, 2s2, 2p4. Now there's an easy way to do it, and that is, instead of starting from hydrogen, start from helium, which is the nearest noble gas to oxygen. So helium, then you go 2s2 and then 2p4. There's no need to do 1s2 because helium, that's already built into helium. That's easy. Now you can figure out the electron configuration for any type of atom. It's from, I don't know, scandium. So with scandium, we need to start from argon, and then we need to do 4s2, right? No, we do 3d. What? Like seriously, why do we start at 3d? It begins with 3, so we need to be at the 3rd shell, but it's at the 4th shell. Seriously, why? So, the solution to our scandium problem lies with the Aufbau principle. So, to understand Aufbau's principle, we need to make a table of all the different subshells. So, first we need to do the S subshell, 1s, 2s, 3s, 4s. You can go all the way down, but these are the only ones we need to solve our scaling problem. Then the p's. 2p, 3p, 4p. There's no 1p. And then the d's. 3d, but there's no 2d. And then 4d. And then 4f. Now, Aufbau rule says that you need to go diagonally when filling up these subshells. What do I mean? Let's see. So you start at 1s, go diagonally from there, and then you go 2s, diagonally from there, 2p, diagonally from there, 3p, diagonally from there. Notice, we've done 4s, but we haven't done 3d yet. So this means we actually fill up 4s before we fill up 3d. Okay, that's quite simple. So now our scaling problem solved. It's just 4s2 because the s orbital can hold 2, and then b1. Right? Wrong, 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 wrong. Because of the energy increase rule. Energy has to increase in this. Now, 3D has a lower energy than 4S. So instead of this, we need to write noble gas notation. 3D1, 4S2. Simple! So now we solved our scandium problem. Then you learned Aufbau's principle. So that was the end of this video about electron configuration and Aufbau's rule. That sounded very interesting, right? Well, it may seem at first mind-bendingly complex, but if you practice, it becomes very simple to understand. So here's some practice for you. Today's quiz question is to find the electron configuration for potassium. Your only weapon here is the periodic table in this video. That's your only weapon here. Try to figure it out, and until then,